Amazing opening session. I'm going to follow up and I'm going to talk about security. I'm going to disagree with Sander on one thing. I'm not exactly sure that not writing security code is going to help your application, but we can talk about that later. I'm actually pretty impressed about Stan, your CTO, picking up on the question mark in the presentation title here. It's a very small nuance, and I'm going to talk about AppSec, application security. I'm going to talk about why it's a hard problem. Nobody's questioning that, I guess. That's the exclamation mark. But I'm also going to try and give you some solutions and approaches to try and help you deal with security, deal with application security. I'm going to talk about ways to reduce complexity, which is probably one of the best takeaways we got from that initial presentation this morning. When I was building this presentation, I kind of had a working title in mind that was a lot more dramatic and allows for some cool things, like the road to AppSec hell is paved with good intentions. And it sounds cool, and you can do a lot of things with that, but the more I was trying to form the presentation to get to where I was going with this, I realized that it didn't really reflect well on what developers are trying to do. Because good intentions means developers, I'm honestly convinced, I work a lot with developers, they want to build secure software. It's just incredibly hard to do so. And that good intention is a very important first step, and it doesn't lead to AppSec hell, absolutely not. It leads to a place where we can improve, sure, things we can do better and get more control over, but that is not AppSec hell. AppSec hell is a company that doesn't care about security. It's like, yeah, whatever. We'll see what happens, and we don't invest in this, and we don't spend time on this, and eventually things will go wrong very badly, and then it's like, oh yeah, whoops, we did not see that one coming, and so on. So that's why the title is a bit more nuanced, a bit less attractive maybe, but the content is not less important. How do you build secure software? Let me start by asking a question. What do we expect from developers? We, as in a company, a security team, just the team in general, what do we expect from developers to build secure applications? How do you do that? What are you supposed to do? And the answer is actually very easy. The answer is like, yeah, just follow secure coding guidelines. I mean, we have so much information out there on how to do things securely and how to get things right, and that's what you're supposed to do. But it's very easy to put on slides. That's kind of my job when I speak about security or teach people about security. It's just a bunch of slides. But doing this in practice, which I also do with companies, is really hard. Doing this in practice means you have to take a whole bunch of guidelines into account. And when I do a workshop, a security workshop with developers, it's a 2-day workshop. And at the end of those 2 days, I have covered an enormous amount of guidelines. It's like, oh yeah, here's 5 things to do here, and then this topic requires these guidelines, and here's a best practice for this, and so on, and so on, and so on. It just keeps on coming and coming. And by the end of those 2 days, people are fried. Their brain is absolutely full of information. So when I tell them that the closing presentation is like a 90-minute recap of everything, no, that's a joke. I don't recap. I recap every module with best practices, but the more I'm doing that, I started realizing, where is this going? How is this even possible to do that in practice? Because it's not only about security. When I'm there, it's security and nothing else. But in your day-to-day job, it's not just security, it's also performance and scalability and accessibility and this and that, and you have to keep all of these things in mind, and it simply doesn't work. That's maybe the most important takeaway from this session here. It doesn't work. I've seen it over and over again, and it's good. It moves us in the right direction, but there's additional things you'll need to do. There's a way you need to grasp this and try to abstract it away. That's essentially what I'm going to try and talk about today. I'm going to give you 2 very concrete examples on how things go wrong and what you can do to kind of forget about the problem altogether and solve it once and for all. Before we do that, a quick word about myself. I'm Philippe De Ryck. I'm from Belgium, so it's kind of nice to speak without traveling too much. And I run my own company called Pragmatic Web Security. So what I basically do is I help developers understand security and build more secure software. I do that through training, workshops, courses, and also a specialized consulting as well. All right, enough about me. Let's talk about security. I want to give you one example, a React example, just because it's something very easy to understand and something a lot of people these days work with. It's, I think, one of the most popular frameworks, front-end frameworks we have today in one form or another. And when you're building a React application, front-end web app, JavaScript, there's one critical vulnerability you have to take in mind, and that's cross-site scripting. the execution of malicious JavaScript code. That's a no-brainer if you're building any front-end thing. Used to be back-end server pages where you had this problem. Now it's a front-end problem and a front-end responsibility for addressing this. So what does that mean? Some practical examples. It means if you have a snippet of code on top, like a React template, JSX, to output some data into a page, eventually it's going to render some HTML to the user, right? And a malicious user, this is a restaurant review application. Well, it's a very small part of a restaurant review application. This is going to show reviews. So if you're looking for a place for dinner tonight, you'll go into this application, find some reviews. And a malicious user in that application, they can provide malicious data. They might give you a review that kind of looks okay, but there's some nasty parts in there. At the end, you can see line 4 and 5. You can see an image with a source none. Like this image doesn't exist, and then the malicious user gives the browser a helpful hint, like, oh, by the way, if this shouldn't exist, which is going to be, here's a nice error handler, and the browser will execute that code. This is a potential attack vector for cross-site scripting, a malicious payload that might result in a problem. Now, what happens if you do this in React? Well, the browser is going to render this template. It's going to end up in a browser. Browser rendering engine is picking it up, and it's going to show you something like this. And it looks like crap, first of all, because I really suck at design, so that's part one. But the second thing is you see all the characters in there. You see all the little tags in there. That's because React is applying something called automatic escaping. Every front-end framework today, every modern framework today is fully aware of this problem and says, like, you know what? If you're going to put data into a page, we know that that's dangerous, and we're going to make sure that it doesn't result in the execution of malicious code. That's awesome. This is a really big step forward. So whenever you use data binding with the curly brackets, the stashes, you are good to go, and this will result in the displaying of the data, not the execution of malicious JavaScript. Awesome. Not a very good start to this security issue. So what's the real problem here? The real problem is that in many cases, you actually want to see some pretty data. If your customer is like, yeah, we want to have like this rich editor, we want to create fancy documents and submit them, and they should come back, and they should actually look like the stuff we submitted and not like this HTML junk that you saw in the previous picture. And this means you need HTML rendering. That's essentially how these things work. This is CK editor, by the way, maybe an ancient editor, but it's still around. And when you render this or look at the data behind this, you'll see that this gives you, where's my highlighter? Here it is. This gives you headers and paragraphs and images and captions and so on and so on. That's essentially how these things work. So you need to render HTML. If you have Markdown, you need to render Markdown, which turns into HTML and so on. This is really common in a lot of front-end applications. So how do you do that? Well, in React, there's a property to render HTML, and it's called dangerously set inner HTML. You can kind of see where this is going, right? I mean, how do you use that? Well, you can use that property. They make you jump through a couple of hoops to avoid misusing this. Like, are you really sure you want to do this? You have to provide an object with an HTML property and so on. And here we're providing a review. The data is still the same as before. And now React renders that. Well, beautifully is a different word, but it renders the HTML. It shows you the actual code that the tags represent. And in this case, the image ends up in the page. You can see it right here. The image is there, it doesn't exist. The browser picks up the error handler and executes that alert dialog. So you now have a cross-site scripting vulnerability in your application. That's why it's called dangerously set inner HTML. That exposes the underlying inner HTML, which is a known dangerous sink. And in this case, we actually have a potential danger if we use that with untrusted data. All right. First of all, well, a side note here, that alert dialog is not really scary. I'm fully aware of that. This is a proof of concept. If you, as a malicious user of an application, as a tester, as an attacker, can make the application pop up an alert just by providing some data, then you have found a cross-site scripting vulnerability. The only thing left to do is replace the alert code with anything you want to do, like add an additional transaction in a banking app and submit it to the server. Whatever you can think of, you can now execute. So this proof of concept basically means you're in. Now you have to be creative and come up with an actual payload to make something go wrong. A lot of payloads are credit card skimming and so on because, well, that's easy money, but a targeted attack will do some very fancy stuff to focus on the application itself. All right. How do we fix this? If you're a React developer, what are you supposed to do to fix this? Well, one piece of advice is you can use Angular, because Angular does this out of the box. If you ever try to tell that to React developers, it does not go over well. I've done that regularly. Whenever I talk about React, I tell them like, yeah, just use Angular. And then we go off into this crazy discussion why I'm an idiot and I shouldn't be saying things like that. And they're right for some things. But different topic here, different story. Let's talk about React. There's actually a solution to this, and the solution is universal. The thing Angular does out of the box is sanitization, and in React, and in Vue, and in Svelte, and all the other frameworks, you're supposed to apply sanitization. That's a best practice. That's a well-established practice against defending against cross-site scripting. You sanitize data whenever you want to see HTML. And a sanitizer, in this case DOM Purify, is an example of a sanitizer. That sanitizer will take that untrusted HTML, it will go over it, it will make sure that anything that's potentially or that's not known to be safe is taken out. So in this example here, the sanitizer will go over this. It's a bold tag. It's like, yeah, bold is known as safe. That's fine. We have anchor tags. There's some conditions there, but in general, they're known to be safe. That's fine. And then we have the image tag. And the image tag is listed as safe. Good. Image tag has attributes. Source attribute. Oh, yeah, we know source. That's a good one. On error attributes. Oh, that's not on a list of safe attributes. And it will be removed. The sanitizer will remove these things, and off you go. So what you get is you can actually assign this into the page with dangerously set in HTML. You get your HTML, you don't get your cross-site scripting attack vector, and you have done a good job in protecting the application. That's essentially what you are supposed to do in React applications, and the same holds for all the other apps. This was a backend responsibility at first. We applied sanitization there. Now we do it in the front end in your framework of choice. That brings us to a first takeaway. I'm going to have a couple of takeaways here. The first one is it's very important to avoid accidental misuse of dangerous features. That's what React is doing here. They're trying to prevent you from making a mistake by calling it dangerously set inner HTML. Why? Because if it's in the browser, it's called inner HTML, and it doesn't signify that this is dangerous. But React does that for you. Why? Because if you I used to say copy-paste stuff from Stack Overflow, but today it's if you copy-paste stuff from ChatGPT, it now says in the code snippet, dangerously set in HTML, and as a developer, you'll be triggered and think like, why is it dangerous? What should I do? To be honest, I haven't checked if ChatGPT gives you sanitization out of the box. I probably should look into that after this session. All right, marking dangerous features or dangerous application features as dangerous, that's a very common pattern these days, and it's a really important and good pattern. Something you can use in your own applications as well. If you have a function that does something that can be misused, indicate that in that function, in that library, so you know that for the future that this might be dangerous. If you think about this pattern, it's a bit weird though. Because we're basically telling developers like, hey, this is dangerous, and that's it. You don't really help them solve it. It's just like, hey, this is dangerous, watch out. And that's where the story ends. And I'm not sure if that's the best approach, if that's the best we can do. If you encounter this, let's walk through the mental steps. So as a developer, you encounter this property dangerously set in HTML. You don't really know what it means. Maybe you do. In that case, good for you. If you don't know what it means, you have to look it up. So you have to find out, like, why is this dangerous? What's going on here? And you'll find the documentation. This is the React docs. And the documentation is saying, like, yeah, this is dangerous because of cross-site scripting. The code example isn't very applicable, to be honest. The code example here doesn't really show you the dangers of cross-site scripting. And they don't mention a solution either. There's no mention of sanitization. It's just like, yeah, remind yourself that this is dangerous. The end. And that doesn't help you get your job done. That doesn't help you as a developer to be as efficient as possible in writing good and secure code. And this eventually leads to problems. This leads to problems. Here's an actual case of this exact problem in a desktop application for Signal Messenger, a secure messenger. And the desktop app was written in React, running on Electron, and they had this exact cross-site scripting vulnerability. And that's a bit of a problem that we have to deal with. We're marking things as dangerous. That's a good practice. That's a good pattern. We see that across a lot of different frameworks, but it's not enough. It's not enough to avoid the problems. It helps in accidental misuse. It helps in copy-pasting stuff or auto-completing things without thinking about it. It will remind you, like, hold on, you have to think about this. But it doesn't magically make things more secure. You still have to figure out how to do things right, find the right advice, apply the right advice, and get this done in practice. And even if you follow best practices, like I showed you earlier with dump purify, that's a best practice, your code base is still going to be filled with these dangerous features. It's still going to be everywhere. And that creates a second problem we have to deal with. And that second problem is, how do you know if your application is secure? Have you sanitized all your outputs? Well, how do you check that? You can do a code scan. SandGrab is a really awesome tool, by the way. If you never use it, look into it. It's absolutely perfect for things like this. It's a static analysis tool, but kind of a dumb one, as in it doesn't really try to understand your code. It just looks for code patterns. And because it's not very fancy or elaborate, it's super fast. As in, you can run this in seconds, and it will tell you, like, hey, here's some code patterns that are concerning. And if you run this on this demo application I had, it will show you something like this. We scanned these files with a bunch of JavaScript rules for React applications, and it pops up saying, like, hold on, you're using dangerously set into HTML. That's dangerous. Because of reasons like this, they actually hired someone to improve the documentation. So they used to have the official React stuff, which wasn't very meaningful. And they hired someone to work this out and give you actionable advice saying, like, hey, you want to make sure you sanitize this, and so on and so on. This is awesome, because you can run this on your application, and it will tell you exactly where you're violating best practices, where you're doing things that are potentially insecure. SandGrab doesn't analyze your code. It doesn't understand where profile.bio in this case comes from. It doesn't know if this is user input. It just says, like, hold on, dangerously set in HTML with a variable, that's bad. You're supposed to apply sanitization, otherwise we're going to mark this as dangerous. And that's kind of a pattern that's emerging in large teams to make security scalable, and we call this developer guardrails. Like the guardrails in a bowling alley, they help you or prevent you from getting off track and ending up in the gutter. And in this case, the guardrail is about being careful with using dangerously set in HTML without sanitization. That's it. Don't do it, and you should be good to go. All right. So if you do things the right way with dump purify, as you can see in this code example, this is the same example as before, so nothing changed. SandGrab recognizes that and says, like, oh yeah, that's good. That's how you're supposed to do it. I'm not going to complain about that instance. Awesome. If you do something else, maybe you put dump purify or call dump purify in a function, and you call that function in your component, and now your template looks like this with sanitized HTML. SandGrab doesn't really recognize that. So even if you fixed it in a different way than expected by the analyzer, it's going to come back and say, like, yeah, I don't know about this, because I just have a bunch of rules, and the rules talk about dump purify, not about this whatever you're doing. So this is still not the greatest practice. But it's fine, right? Because we can look at this. We know what a sanitized HTML does. It does one thing. It takes input, sanitizes it, and returns it. So we can decide, like, yeah, thank you for the warning, but this is good. Awesome. Now, this is a training app, and you can see that here. It has 3 files, runs 6 rules on 3 files. That's not a very realistic application scenario, especially if you have a few hundred repos. It's not going to be only 3 files. It's going to be a lot more complicated. And if you run this on whatever, 123 files, 5,000 files, however large your application is, you're going to find dozens and dozens of these warnings. And you have to go through each and every one of them to analyze, like, yeah, this one is fine. Oh, this one we forgot, fix this, and so on and so on. But in the end, even if you use a sanitized HTML function, which will call dump purify, which is secure, we still get those warnings in our code base. And that gets in the way real fast. Because if there's one thing developers hate, if you run security tools on a code base, it comes back with this 15-page report of stuff. It's like, oh, crap. Then you have to look into it, and sometimes it's like, yeah, whatever. And the tool gets tossed. Wouldn't be the first time that a company brings in like a static analysis tool, they get bogged down with all the false positives and crazy reports, and they just throw it out again, like, yeah, this doesn't work, whatever. And they keep doing the same thing. But you can fix this. And that's kind of a very important pattern. The way to fix this is to avoid using these dangerous features throughout your entire application. Yes, you may need them, but it's insane to think that every developer in your team will know about the best practice of using dangerously set in HTML, because there's so many more things to know about. It's insane to think that if you hire someone new and they start next week or June 1st or after the summer, whatever, that they'll get up and running and know all of these things. If you hire a junior developer, they won't know about how to use dangerously set in HTML securely. And it's absolutely impossible to keep track of all of these guidelines. So we need these tools to scale security. But in order to do that, we need to adjust our approach to writing this code so that the tools can actually work and do what they're supposed to do. And the solution here is to encapsulate this behavior. There's no point in teaching everyone how to do this correctly. What you can do is you can just say, forget about using dangerously set in HTML with the exact right configuration. Instead, here's a component, a React component called save.html that does exactly what you want it to do. You want to output HTML, we use save.html or whatever you want to call it. This is a custom component. We tell it what element to create, a paragraph, and we give it HTML to show there the review. And that's it. Clears up all of the confusion and gets rid of dangerously set in HTML in that template, in that component, and you're good to go. And you can do this across your entire code base. And the component is, like I said, a custom component. It's very simple, very straightforward. And behind the scenes, it does exactly the same thing as we've been doing before, but in one place instead of in 50,000 places in your code base. So now we do it once, and we're done. And all you need to know from this point forward is, want to output HTML, we use save.html. That's a very easy guideline, and it kind of automatically does security for you. Output HTML, don't need to look up how to use, just use this one, done. And that by itself is awesome. And this is something you should really be doing because it will simplify your code. It will encapsulate this particular security behavior, these details in a component, and absolve every one of you from having to know how to do this. The advice basically went from learn how to use DOM Purify or whatever sanitizer correctly, and so on, to use this component, don't worry about the details. We got you covered. And who does that? Well, somebody in your organization can do that. If you have a security team, they should be helping you build up these libraries to get these things done so you can do your job and they can handle security. Or if you have senior developers, senior architects, whoever is responsible for setting out the guidelines should look into doing things like this. And it gets better. Because if you run semgrep on this application with a save.html component, we have 0 findings. Why 0? Because there's only one use of dangerously set in HTML, and that's in that save.html component, and that one uses DOM Purify in a way that semgrep likes, and it doesn't complain. If you do something else, you could also add a comment to tell semgrep, like, yeah, let's keep this line our little secret, don't complain about that in the future, and we should be good to go as well. But the 0 findings means something. Because 0 findings here means that if you run it again after somebody made a mistake, use dangerously set in HTML directly, semgrep will pop up and say, like, hold on, what's this? You can run this in PRs. You can block a PR if semgrep says, like, yeah, there's findings. You can automatically block the PR from getting merged to look into that and make sure that the developer that wrote the code learns what's going on and can fix the problems. And that's how you can scale things in practice, with tooling and with a code base that supports tooling to be as efficient as possible and to get this done. And that's really important. Scaling security here with encapsulation for one. Encapsulate complex behavior in libraries so everybody can forget about that. And then use tooling to ensure that mistakes don't end up in your code base. And that allows you to apply best practices at scale. All right. If you're not a front-end developer, if you're like a back-end developer, don't worry. Let's not talk about React anymore. And let's open up the other can of worms called Json Web Tokens. Json Web Tokens allow me to make the same point again. So I'm going to repeat myself a bit, but in a different context and with maybe a bit more disastrous consequences as well. And it's a different perspective, very widely used technology. Everybody in the world is using Json Web Tokens these days. Every developer comes in touch with Json Web Tokens, and they're a nightmare to handle securely. And again, there's a whole bunch of guidelines to follow that may or may not be that easy to get done. So what's a JSON Web Token? A JSON Web Token is a JSON data structure, consists of a header and a payload, both JSON objects, and Their purpose is to represent claims securely. That's essentially a JSON Web Token. So we have a base64 encoded JSON object, and we have a signature at the end. And that signature, there's various ways to do that. I'm not going to go into the details. That signature is intended to protect somebody from messing with the data in that JOT. So if you send, or if your application receives a JSON Web Token from somewhere and sends it to a backend, the idea is that the backend will verify that signature. And if somebody changed their role from user to admin, the backend will be like, yeah, nice try, go away. Let's not do that. That's how JOTs are very often used, and that's why the signature is there, to offer integrity protection for the data. So when you see stories like this, that's a reason for concern. Apache Pulsar, major open source project. This is a story from 2 years ago. They had a bug, a critical vulnerability, that allowed account takeover. That basically allowed someone, a malicious user, from taking a JOT from the application, changing whatever the hell they wanted, sending it back to the backend, and backend was like, yeah, good enough for me. You are now admin. Awesome. Welcome. And you could do whatever the hell you wanted. A story like this should scare you, because this applies to a lot of applications depending on Apache Pulsar. So I looked into that, and the story actually had a lot of details of what's going on, and they linked to a pull request that fixed that vulnerability in the application. So the JOT vulnerability, pull request, so the code in red on the left goes out, and the code in green comes in. And this paints a very interesting picture. So if you look at that, so the bad code basically says, like, we create a parser, and we set a signing key for validating that signature. That's how it works. And then we parse that token, and that's not good. Okay, yeah, sure. So what do we have to do instead? Well, we create a parser, we set a signing key, and then we parse that token. But we use a different parse function. It's like, huh. Okay then. Like, what? No, that... Why is the left wrong and the right right? I have no idea. I don't know this library, so I couldn't figure this out just looking at the pull request. So I whipped out a code editor in light mode. My apologies for that. And seriously, I don't like dark mode, so we can talk about that later. Please don't kill me after the talk. And if you look at this library, we build a parser, we set a signing key, and then we have 6 parse functions. Awesome. And apparently the first one is bad, according to a pull request, and the third one is good. And I'm kind of, on my good days, I kind of know a couple of things about security, and I'm like, what? I don't understand this. Makes no sense. It's a Java library, so there must be some Java doc with a beautiful framed page somewhere. I couldn't find it, but the open source library, they had documentation. So if you read the documentation, you don't have to read through the whole text. Nowhere does it say anything about a potential security bypass or vulnerability. It's like, what? Well, if you're a careful reader, you may have figured this out, because somewhere around here it says a signature exception. And that one is supposed to be thrown if validating the signature fails. But there's a very, very nuanced wording here, because it says if a signature was discovered. Which obviously means if no signature was discovered, then we'll not validate the token, we'll just accept it as it is, and everybody's cool, and let's move forward. That's the vulnerability. Seriously, that's the vulnerability. That's why this was wrong. And it's called the Elginon Problem with JSON Web Tokens. And Elginon basically means in the header on top you have an algorithm claim, ALG, and that specifies how this token is signed. And one of the valid values, according to the spec, is none. Meaning that in many libraries, like this one, there's a code path that says if elg is none, don't verify the signature, just return the payload back as the claims, and we're good to go. And that means that an attacker, if you have a project like this, a product, an application like Apache Pulsar, it means the attacker will try this out. They'll be like, oh, I'm going to create a token, I'm going to set elg to none, I'm going to re-encode it and submit it to the application and just see what happens. And if it doesn't complain about that, awesome, because I can now craft my own tokens. I can, in this base64 encoded JSON, I'm going to say, like, my role is admin, and I can do anything I want in the application. I'm going to send a request, and the application is like, yeah, that's good enough for me. Now, an attack like this sounds mighty complicated. But if you ever want to go to the dark side, well, we also have non-dark side hackers these days, but if you want to go to the dark side, there's a burp extension called Json Web Token Attacker, and that burp extension has like a drop-down that says elg non-attack, click. And it will automatically re-encode the token, change the header from elk to none, allow you to update the claims in a nice text editor, and send the request, and off you go. It's literally point and click to make this attack work, and it's absolutely awesome. This problem occurs quite often. It's a problem we've been dealing with for more than about a decade now, the Elginon problem, and it pops up in all kinds of forms and variations. Because people learn about it and like, oh yeah, we're going to add a check to our code base that says like, if elk is none, reject token. Which is good, but they forgot that elk can also be, the none can be capitalized, and the check wasn't. So an attacker, like the drop down from the previous slide, the drop down with the Elginon attack allows you to choose your capitalization. There's a bunch of options. And this is not a joke, this works in practice. Well, it worked at least in practice. And this is a big company. They should have known better. And they learned a very harsh lesson when this story came out. But the takeaway here is that these things are going to happen. You should include these common pitfalls in your test scenarios. That's the first part. And this is a nice link to the first presentation this morning. When they talk about testing, when you have like this whole bunch of crap that is not supposed to happen, this is one of the things that is supposed to be in there. Your application should have this test with a token, with the correct Elginon representation of that token, send it there, and it should come back with an error message. And you should also test for Elginon with capitals and make sure it comes back with an error message. Because if you would have done those tests, and you would have made a mistake with this library, your tests would have said like, hold on, there's a slight problem here. And that's good. And to be very honest, if I would have used this library in my applications, I would have very likely made the same mistake. I will not give myself credit for being able to choose the right parse function. I would very likely choose the wrong function as well. But whenever I have an endpoint, and I do that with my customers as well, whenever there's an endpoint dealing with JOTs, I have this battery of tests that throws all kinds of crap at it, and they should all come back with failures. That's a very generic test suite you can throw at any endpoint, because it should all come back with the same error like, no, you're not allowed to access this. And then you will catch problems like this. But let me link back to the title of the presentation. I think by now, it's very fair to conclude that AppSec really is too hard. I mean, why should you have to learn about all of these things before you can actually get it right? I mean, talk about Json Web Tokens, the story actually gets a lot worse as well, because handling Json Web Tokens is really, really hard. It seems easy, and every tutorial you'll read online is like, yeah, it's easy, just do this and do that, and bam, you're done. But there's a whole bunch of things that go into that, especially if you're building a service that also generates JSON Web Tokens. Because you have to choose how to sign them. There's two options. You have HMACs or digital signatures, and you should use digital signatures. That's the color coding here. HMACs are useless. Forget about them. And yes, I'll fight you on that. We can talk after the presentation. But that's one decision you have to make. Second decision, okay, we're going to use digital signatures. What signature scheme do we use? There's a bunch of algorithms. Like, oh yeah, we can use one of these. And the best one here is EDDSA. That's considered to be a best practice. Use that one. But also the one that is not supported by most libraries. You'll have to search really hard to find a library supporting that. So what's your pragmatic choice? What do you want to do here? Go for the best that's not supported. Please don't write your own signature verification. Or, in this case, my advice would be choose a pragmatic one. PS256 is RSA-based signatures with the right padding, whatever details. That's a sane choice. But in reality, everybody's using RS256 because that's the standard. That's what every tutorial, every example, every major service uses, and it's very convenient to do so. Next, you have to verify that the JOT is valid. If you're consuming a JOT, and that means you have to verify the signature correctly, not using that parse function from that library, but the other one, Parse Claims JWS. You have to check reserved claims like the EXP and the MBF claim, timestamps, expiration, and not before. Make sure these timestamps fall within the limits of what you expect. You have to check the audience and the issuer claim, making sure that the issuer is a trusted service, the one that created the JOT, and the audience is you, the one consuming the JOT or your service. And my slide is full, but I have more issues. You have to take care of key rotation. So eventually signing keys have to be rotated and your system shouldn't go down because of that. So you have to use key identifiers and key sets and so on and so on. And you have to think about using explicit typing for JSON Web Tokens to avoid token confusion attacks. There's actually an RFC on crap that goes wrong with JOTs and stuff you should do to get it right with JOTs. That's essentially how complicated it is. If you're like, what? I need to learn about these things. I wrote this in a long format text as a guest post a year and a half ago. Yeah, a year and a half ago by now. So that goes into a lot more details on these attacks and best practices and so on. So you can read that one if you want to learn more about JOTs. That's a lot of guidelines. Remember when I said in the beginning, like, it's not really feasible to expect developers to know all of this? Now imagine you're working in a team, in an organization, a dozen, 50, 100 developers, and they all have to learn these guidelines, and they all have to come up with the same guidelines over and over again. It's not going to work. It's a mess. And it's absolutely horrible to expect, or impossible to expect, everyone from learning this and following these guidelines and not make a mistake against that. And in many cases with JOTs, making a mistake means authorization issues, authentication issues in your application, major vulnerabilities. So I'm going to repeat myself from 15-ish minutes ago. There's no reason that everybody should be dealing with this over and over and over again, especially because very often it's the same features, just a different service, a different this, a different that. So why don't we encapsulate this behavior? Why don't we ensure that if a developer has to deal with that in your organization, there's not going to be 15 different ways of using JOTs, it's going to be one. And in this case, it's an authentication token representing who the user is. Can be an OAuth access token or some custom thing you're doing, that's all fine, but encapsulate that in a library. Because that absolves you as a developer from having to know how to verify this JOT. It's just like, oh, we need this JOT, bam, throw it in there, comes either back with an error message or with whatever we need to do whatever we need to do. And from a security perspective, it simplifies things, because now you have to worry about handling JOTs once. You can test this extensively, you can make sure it works the way you want it to work, and then just tell everybody, we got you covered, you can use this in the future. And it makes everything simpler. It removes this whole bunch of tests and checks and verification and libraries and all of that from your main application, from your main code base, and pulls it out into this one library for handling that JOT. Done. And it also gives you flexibility. Because if you want to upgrade the signing algorithm, if you want to change something, you change it once in the library, and everybody benefits from that. You don't have to go over the entire code base, fix things here, fix things there. It just makes things a lot easier to deal with. And this is not some groundbreaking revelation I came up with. This is just something that has grown over time from talking to developers. And I'm by far the only one making these conclusions. We talked about Netflix before. So sure, why not Netflix? They are building software at scale. They have a lot of developers, a lot of different services. We have the Netflix we know, but they also have Netflix Studios behind the scenes, the one that actually produces the shows. Some of them may be questionable, but that's a different story. But produces the shows, and a lot of people working with that in a lot of different environments, and not all tech-savvy users, and so on and so on. And their approach was based on checklists, security checklists. Like, here's a bunch of stuff you have to do. And the security team would talk to the application developers and say, like, yeah, we have this checklist. Do you have time to go over that? And the application developers were like, no. And then they kept pushing, and eventually, like weeks or months later, they were like, fine, we'll go over your security checklist. And a bunch of things popped up, and it just didn't work. Because, well, especially 5-ish years ago, Netflix wanted to move fast. And moving fast meant not spending a day or 2 days on a security checklist only to get scolded that you didn't do it right in the first place. So they changed their approach to something called the paved road. And they said, like, you know what? Instead of forcing our guidelines on developers, what if we just gave developers a tool that does everything for them? Like a library, but a bit larger in scale. And what they basically did is they gave developers tools that allows them to set up a new project from scratch in 10 minutes. A new Netflix service integrated with single sign-on, domains registered, deployment, pipelines, all figured out in 10 minutes. And the tool auto-configured security, enabled authentication, enabled authorization, handled incoming JOTs, and so on, all in 10 minutes. And that approach was massively successful in getting grips on security. Because now you give developers a tool like, hey, this makes your job easier, and it does security, so you don't have to worry about our pesky guidelines that we have to go over. And developers are like, yes, please, thank you, bam, and done. And this approach really works to scale security. And incorporating security in this way, instead of trying to add it on and trying to force it on people, is very, very pragmatic and very useful in scaling security to your entire application code base. Instead of doing the same thing over and over again, checking the same things over and over again, try to give it for free with easy-to-use libraries and components and frameworks, for that matter, that just make everything better. All right. Takeaways. What do you want to remember? Well, security is hard, kind of in the title, the exclamation mark. But it's not hopeless. We can definitely get security right. But it will take some effort. It will take some growing, some learning, some experimenting, and figuring out how to move forward with security in your team, in your organization, and across different applications. So takeaway number one, security awareness and coding guidelines are important. I'm not saying to throw that all away. It's knowledge that we've built on for decades, and it's absolutely valuable. I believe that every developer should have at least some security awareness to make sure that their spidey senses start to tingle if they're doing something security relevant. Like, what are we doing here? Are we sure this is the right way? Let's find someone who knows and get this figured out. Number two, encapsulate security behavior to simplify your code base. Instead of doing the same checks in this application and in that application, just come up with one generic approach to do it so you don't have to reinvent the same code over and over again, rewrite the same code. Because if you make a vulnerability in one, it's going to be a problem. And having that in a central place, encapsulated and shielded off, vetted for security, it's going to make things better. And then number three, leverage tooling to scale security. Tools like SamGrab are used at major companies with hundreds of developers. Slack is one of the front runners that started using SamGrab really early in its life cycle. And it's really, really useful to figure out these dangerous patterns and just improve the overall quality of your code base. All right, before I wrap up, shameless plug here. I'm one of the organizers of SecOpDev, a course here in Belgium, where we have speakers from all over the world to talk about application security. It's a non-profit course, so I'm not benefiting from you being there. I just wanted to point out that we have really in-depth lectures, hands-on workshops with true experts in AppSec. So if you want to learn more about application security, definitely check it out. And with that, I want to thank you for being here. I hope you enjoy the rest of the day in this awesome conference with an amazing lineup. There's some security talks, so make sure you check them out as well. And if you have any questions, I'm here in the break, during the break, so we can definitely chat then. All right, thank you.